will talk about the radio workshop which we had 2 days ago. Floor is yours, Hervé.
Okay, can you hear me like this? Yes, I think so. Good afternoon, everybody. So yes, we organized 2 days ago a radio workshop for the second time actually, and Sis asked me to kind of make a wrap up of the whole thing. And thank you also to Daniel. I don't know where Daniel is, but thank you for Daniel for assisting me in making this presentation. So I should go here. So first, let's start with some statistics. We were 17 people here and 8 participants online. So yes, that's a bit annoying. We don't see the title, but basically what was this workshop about this time was mostly about head echo. So I took this slide from the presentation of Yua, because it shows basically the difference between Meteor trail, where you have reflection on a very long trail created behind the object, where you have a really big radio cross-section. So these ones are typically specular and can be studied by conventional meteor radar, while this workshop was mostly dedicated to head echoes. So this is this region, this dense region, plasma region, in front of the objects and moving with the object itself. So these ones, the radar cross-section is much, much lower. So they are usually studied with what we call high power, large aperture radar. So the main topics that we covered during this workshop were the following. So there was a very nice presentation by Meers Oppenheim on the physical modeling of the meteor phenomenon itself, going from picoseconds to seconds, and I will illustrate that in a few slides. There was mostly a discussions about how to observe meteor head echoes. We did not really have a presentation about that, but we also had a nice presentation by Daniel, who explained how to process these meteor head echoes. And finally, we also had a really nice talk by Yua, who gave us an overview of existing database of meteor head echoes, and in particular, he compiled about 2.5 million echoes and associated orbits. So these are the type of meteor of radar systems, that were used for these studies. So this is here the Mu radar in Japan, mostly the data that Daniel presented. And UA used data from PANSI system in Antarctica and from MARSI system in the north of Norway. This is an example of raw data that we obtain with this system. This is from the Mu radar in Japan. This gives you an idea about what you get from the radar. So here you have the power. Here you have the information from the interferometer. You have the range here. You have the Doppler speed, and you have the signal-to-noise ratio. So from all this, Daniel explained how to process this data. And this is the kind of results you can obtain. On this one, so this is kind of a scatter matrix of the final results, where you have on the diagonal all the reconstructed of the outputs, basically from the position, from the directions, from the speed, and the deceleration parameter. So, and you sample the solutions, the posterior solution, which gives you confidence intervals. And on the diagonal terms, you have the correlations between the parameters. So some of them are not correlated, or very, very few correlated, but some others, like these ones, are extremely correlated. So you have all the information from this analysis. So as I said, Meers gave this very nice talk about the physics of the meteor, and I took this slide. So I hope this will work. There are 2 movies. So this works. So this one, I remember well, is the simulations that they made for one particle from the atmosphere impacting the surface of the meteoroid. So what you see, you don't see the particle because it goes really fast, but you see how the energy, how it excites the molecules, the atoms of the, so you see all these vibrating and heating up, and you also see a few of the particles sputtered from the surface. Now this is for one particle. Now if I do this, nope, sorry. How can I play the second movie to the right? Can you play it? Or? Yeah, you have to pass. Yeah. Now this is many particles. I don't remember exactly how many of them, but the time frame you see is very slow, and you see what's happening now. This kind of ablation stuff. So very cool simulations. And then I very briefly presented our first attempt to use the Brahms data. So you see one example of the Brahms data where we see here, oops, you don't see it. Here. Where is it? Yeah. You see the head echo followed by the tail echo, and we try to measure this and see if we can estimate the speed of the object. And to do that, we did a little bit what Joachim did during his thesis that he will present later on. For trade echoes, it is reconstructing using Brahms data and comparing to existing optical observations, in this case from Frippon fireball, where you see here one that was detected above, well, nearby Brussels, and here was the trajectory, and this is the corresponding Brahms data. And finally, we also had a few amateurs participating to this discussion, this workshop. Hans Wilskut, so he gave a talk, and from the conclusion and the discussions afterwards, it was concluded that actually we need more assistance in data interpretations from the professional. So in conclusions, I will very briefly, this is my conclusions. So I think there were really great talks given. There were lively discussions, so I think it was very enthusiastic. So for me, it was a success, this workshop. I think everybody there agreed on that. So we'll do it again. And I think I will probably do it myself. Thank you. Thank you, Evie. Do you hear me?
Can you hear me now? Okay, it's on when the light is off. Thanks. So are there any questions in the room? Any questions in the room? If not, are there any questions online? I can't see any, but let's wait a few seconds. If not, then let's thank the speaker again. And